Today, we're going to pop the hood on a modern web application and see what actually makes it tick. We're going from that high-level blueprint all the way down to the nuts and bolts. So let's dive right in.
Have you ever been using an app and just wondered, what does this actually look like for the people who built it? Is it just a crazy wall of text, a bunch of random folders? Well, we are about to pull back the curtain and find out. So before a single line of code can do anything cool, it has to be organized. Seriously, think about it like you're building a house. You wouldn't just start throwing bricks and wood together without an architectural plan, right? Of course not. In the software world, that plan, that single source of truth, is the project repository. For our little tour today, we're going to be looking at a real-world example, a simple to-do app that's hosted on GitHub. This is what's called a full-stack application, which is just a fancy way of saying the repository has everything in it, from the buttons you click on screen to all the server magic happening behind the scenes. Okay, so the very first thing to wrap your head around with this project's blueprint is that it's a mono repo. Now, I know it sounds a little complex, but the idea is actually super simple. Instead of having one project for the part the user sees and a totally separate one for the server stuff, they all live together in one big, happy, organized home. This saves so many headaches, mainly because it makes sure every single part of the project is using the exact same version of any shared code. And when you look at the structure, it's just incredibly logical. You've got the apps folder, well, that holds the actual applications you'd use. Then packages, that's where the shared code lives, which is great because it stops developers from writing the same thing over and over. Tools is full of helpful little scripts, and docs, well, that's the instruction manual. See? Everything has its own perfect little place. All right, so now that we've got the lay of the land, let's zoom in on that apps folder. This is where we find the two beating hearts of the entire application, the front end and the back end. And this comparison just illustrates the difference perfectly. Think of the front end as the storefront of a shop. It's everything you, the customer, see and touch. The pretty layout, the buttons, the colors. In this project, it's built with tools like Next.js. Now the back end, that's the engine room or the warehouse out back. It's where all the data is stored, where the heavy lifting logic is processed, and where the real work gets done, using powerful tools like Python and FastAPI. You never see it, but that storefront couldn't possibly function without. I love this quote. It just captures that relationship so perfectly. The front end is the beautiful performance you came to see, all polished and easy to interact with. The back end is that incredibly complex system of stagehands, lighting rigs, and sound equipment that makes the entire show possible. One can't exist without the other. They're both absolutely crucial. So we get the structure and we get the main components, but what are they actually built with? Let's take a look at the project's toolkit, the specific programming languages and the commands developers use to actually bring all of this code to life. This chart tells a really clear story. You can see right away, TypeScript and Python are the big stars of the show here. TypeScript, at 43%, is what's used to build that user-facing front end, our storefront. And Python, at 36.5%, is what's powering the back end, the engine room. This is a really classic, really powerful combination you'll see all over modern web development. Okay, so having all this code is one thing, but running it, testing it, and getting it ready for the real world, that's something else entirely. Developers, they don't want to perform dozens of complicated steps by hand every single time. So what do? They create shortcuts. And these are basically the magic words. A developer uses a tool, in this case it's called PNPM, to run these simple commands. Instead of some long convoluted process, they just type PNPM dev, hit enter, and boom, the application starts up on their computer. Want to check for errors? Just type PNPM test. The big takeaway here is that these simple commands automate really complex tasks, and that makes the whole development process fast and way more efficient. We've seen the blueprint, we've seen the components, and we've seen the tools. But modern software isn't built in a vacuum by some lone genius typing away in a basement. It is a team sport, and it's often played on a global scale. And this is especially true for what are called open source projects, like the one we've been looking at. The code is public, which means it's inviting anyone from anywhere in the world to come take a look, suggest improvements, and actually contribute to making it better. It's an incredibly powerful collaborative model. And look at how straightforward they make it for someone to just jump in and help out. First, you clone it, which is basically making your own copy. Then you run that install all command we saw a minute ago. You make your fix or add your cool new feature, you test it to make sure nothing broke, and then you submit it for other people to review. It's a really clear, structured process, and it's all designed to encourage collaboration. And that's really the key. That constant loop of improvement, proposed by a huge community, tested automatically, and then reviewed by peers, that's what allows software to evolve and become more robust and more powerful over time. It's a living, breathing thing. So, as we wrap this up, here's something to chew on. We're stepping into an age where AI can write incredible amounts of code for us. In a future like that, is it possible that the most valuable human skill will shift away from writing individual lines of code and more toward architecting and understanding the overall blueprint, just like we've done today? Will we become the chief architects of these digital worlds rather than the bricklayers? It's a pretty fascinating question to think about.